Good morning, dear students. I am Dr. Srinivas Bathini, Professor of Chemistry in St. Peter's Autonomous Engineering College. Today, we will discuss the introduction of molecular structure and theories of bonding. This is the second unit of the engineering chemistry. What is the first unit? What you have completed till now? The water and its treatment completed. And today we will discuss the unit second. What is the name? Molecular structure and theories of bonding. Molecular structure and theories of bonding. So this is today we will discuss just the introduction. We will discuss the introduction. Introduction of this topic. Okay. Again, I will ask you 2-3 questions. Okay. So what is the importance of this chapter for you? Why we need study at engineering level? That is most important. So whatever we want to study in engineering level, at least what is the use? Is it necessary to read or study or not? That's you must know. Okay. It is completely basic science. Whatever there in 10th class, intermediate. So completely basic. So whatever there in the world, that is in the form of atoms and molecules. Whatever is there, atoms and molecules. Whatever there. You take chalk piece, you take your body, book, pen, universe, and everything. Firstly, basically, atom, then molecule, then body. So you know that the atom contains proton, neutron, electron. What is that? The atom contains the proton, electron, neutron. So here, this is already we know very well. So here, the flow of electrons flow of electrons is what? The flow of electron is current. So without current or without electricity, we can't operate our computers, our mobile phones. Is it possible without electricity? The basic is what? Atoms. In that atom, what is there? Electrons. So without electrons or without current, we can't operate anything, either mobile or computer. Without operator, what is the use? That is the reason we have to read basic science. How it is possible? The flow of electron? We know that the electron present in the atom combines to form the molecules. You know, the atoms combines. The two atoms are there, combines together to form the molecule. Two atoms combines to form the molecule. You know that some of the elements like silicon, germanium are what metals? They are act as semiconductors. What are that? Semiconductor. What are the materials? Silicon, germanium are the metals. So these are act as what? Semiconductors. Semiconductors. Conductors example, can you give me good conductors? Very good conductors are silver, copper, aluminum. Silver, copper and aluminum. These are the very good conductors. These are the semiconductors. These are the conductors. And can you give me the non-conductors? Some are non-metals. Some metals act as non-metals. And in this, they act as some metals act as sensors. You know the sensors. Nowadays we are using the sensors. Remote control, that is called sensors. And some non-metals stop the flow of current. You know that some non-metals like lead, they have stopped the flow of current. Wood, stop the current. Plastics, stop the current. To all these, we are studying these chapters. That is the reason we have to compulsory study these chapters. Whatever computer science or mechanical or civil or EC or any group, the basic science chapter this one. So you must read, you have to must get the knowledge. Okay? Okay now. What are the topics included in this chapter? Okay? What are the topics? What are the topics included? What are the topics? We know that. What are the topics? Already I told you, first topic is the introduction. Today we will discuss the introduction. This is the first topic. Then atomic and molecular orbitals. Atomic and molecular orbitals. Molecular orbitals, the second topic. And third topic is the linear combination of atomic orbitals. What is that? Linear combination of atomic orbital. What is that? Linear combination of atomic orbitals. Linear combination of atomic orbitals. Please note down all these things. Unit second, molecular structure and theories of bonding. The name. And in this, the topics are introduction, atomic and molecular orbitals, LCAO, linear combination of atomic orbitals. Then molecular, the fourth topic is the molecular orbitals of diatomic molecules. Molecular orbitals of diatomic molecule. Diatomic molecules. And fifth topic is the energy level diagrams. Molecular orbital energy level diagrams. MO. Molecular orbital, MO. Molecular orbital energy level diagrams. Energy level diagrams of nitrogen, oxygen, fluorine. These are the diatomic molecule, F2. Okay, nitrogen, oxygen and fluorine molecule. And pi molecular orbital of 1,3-butadiene. Pi molecular orbital of 1,3-butadiene. We have to read this one. Organic compound 1,3-butadiene. And the seventh topic is the crystal field theory. What is the name? Crystal field theory. Crystal field theory. Crystal field theory. Crystal field theory. In this we have to discuss the some salient features. Salient features. And eighth one is the crystal field splitting of transition metals in d orbitals in tetrahedral in shape. What is the name? Crystal field splitting of d orbitals in some transition metals of tetrahedral molecule, tetrahedral structure. What is the tetrahedral? And ninth one, in this also we can discuss the crystal splitting of d orbital, octahedral and square planar also. Octahedral and square planar. Okay. And last topic is the what band structure of solids. Important that is the band structure of solids. Band structure of solids. And final, the very very important topic is what? Effect of doping. Effect of doping on conductancy. So these are the topics included in the second unit. What are the topics? Introduction, atomic and molecular orbitals, LCEO, molecular orbitals of diatomic molecule, and molecular energy levels, diagram of nitrogen, oxygen, fluorine, pi molecular orbital of 1,3-butadiene, crystal field theory, silent features of crystal field theory, and crystal field splitting of d orbitals in some transition elements of tetrahedral structure, octahedral structure, and square planar, and band structure and effect of doping and conductancy. These are the some topics. We have to study in this completely. Okay? Please note down all these topics. Okay? Now, introduction. According to modern theory, an atom consists of nucleus. Modern theory. Atom consists of a nucleus containing proton and neutron, which are surrounded by the electrons. What are that? According to modern theory, an atom consists of nucleus containing protons, neutrons, which are surrounded by electrons. The electrons are arranged in shells. You know the shell. First cell, second cell. Electrons are arranged in cells. Electrons are arranged in cells. That is N. We can say N. Each shell accommodated the maximum number of electrons. We know already in intermediate, 10th class. Accommodate the electron shell containing the boxes. In that electrons are there. I will tell you, these are the basic. Already just revision of intermediate. Okay? Each shell accommodated the maximum number of electrons, where n is the principal quantum number. What is that? N is the principal quantum number. For quantum number. You can say quantum number. Principal quantum number. So what is that? N is equal to, it has values are what? The values. It has the values 1, 2, 3, 4, 5, 6 like that. R, K, L, M, N, O like this respectively. So each cell accommodate the maximum number of electrons. There are some values. The values are 1, 2, 3, 4, 5 R, K, L, M, N, 4 respectively. In every principal quantum number, you know that every principal quantum number again the cell the cell has sub energy levels. In this is the cell 1, 2, 3 like that. In this again divide into subcells. You know the subcells. The cell has sub energy level indicated by the L. Indicated by the L. So you know that L is called as an azimuthal quantum number. Azimuthal quantum number. Azimuthal quantum number. N is the principal quantum number. L is the azimuthal quantum number. Its value, it has value. It has what values? 0, 1, 2, 3, 4 like this. 0, 1. According to the n minus 1 rule, if n minus 1, n is equal to 1, 1 minus 1 is equal to 0. So this is the 0 value. So the 0 is what? 0 is called the s orbital. 0 is the s orbital. S orbital. If n is equal to 2, 2 minus 1, that is the 1. This is the p orbital, d orbital, f orbital like s, p, d, f. Mean that is also this L values always depend upon the n values. Always depend upon the n values. This is already we studied in intermediate. Okay, so what are the orbitals are present in each subcell? So orbitals mean these are the s orbital, p orbital, d orbital. Again divided. The n shall again divided the suborbitals. The SPD states again subdivide into number of orbitals. Again this one number of orbitals. So number mean s orbital containing 1 orbital. If p orbital containing the 3 orbital, again divided into 3 orbitals. And d orbital containing the 5 orbital. 1, 2, 3, 4, 5. So 5 orbitals. Again divided by. How it will come, you know? The total number of orbitals in a given quantum shell is n square. For example, n square. This is the formula. Here n minus 1. Here the n square formula. For example, n is equal to 2. N is equal to 2. How many is there accommodated? N is equal to 2 mean 4. Total number of orbitals are 4. If n is equal to 2 total. That is sp. P containing the 3 orbitals and s containing the 1 orbitals. Like that we will get the values. Understand? So this is the number 1, 1, 2, 3 shells. N. So always that is n is the azimuthal quantum number always depend upon the principal quantum number. So that is if n is equal to 1, that is s, n is equal to 0. If n is equal to 2, that is 1 value will come, that is a p, like that d and f. Again that is subdivided the orbitals in sub energy levels and again divided into, that is n square, that is a number of orbitals present in the each shell. Okay? So these are the just basic. Already we studied in the atomic structure in the intermediate. Okay? And one more rule I will ask you. What is the many rules are there, above principles are there, Pauli's exclusion principle and Ohm's rule. So like that. So according to Pauli's exclusion principle, according to Pauli, so can you tell anybody? No 2 electrons in an atom. What is that? According to Pauli's exclusion principle, no 2 electrons in any system in this one, any system, any system can be assigned the same set of 4 quantum numbers. Can be assigned by the same set of 4 quantum numbers. There can be 2 electrons in an orbital with anti-parallel spins. What is that? Anti-parallel. There can be 2 electrons are there, must be. They are the anti-parallel. One is up, one is down. This is the Pauli's exclusion principle. No 2 electrons in any system can be assigned the same set of 4 quantum numbers. There can be 2 electrons an orbital with anti-parallel spin. One is the spinning upside and the other down. Okay, so this is about the complete picture of the atomic structure. But according to London and Hitler, and London, for the formation of covalent bond, you know what is meant by covalent bond? I don't want to ask the question. This is the basic theory. Now, according to covalent bond, what is the definition? The sharing a pair of electrons is a covalent bond. Meaning the atoms are attracted. Ionic bond, the force of attraction, electrostatic force. So that I don't want to ask with all the questions. Just Hitler and London. For the formation of covalent bond, combining atoms must approach each other. For example, 2 atoms are there. So here, so they should become approach to each other. Then mean they are approach each other in the form of orbitals, and orbital of one atom overlap with other atom. In this orbitals are there electrons, so this is the overlap. This is the overlap. Okay, this, or otherwise I will write. This is the one orbital. Okay, this is the another orbital approaching each other. So this is the what? Overlapping. The bond formation is like that. So that is overlapping. According to whose? Hitler and London, for the formation of a covalent bond, combining atoms must approach each other, and orbital of one atom overlap with the other atom. As a result of overlapping, the new localized bond is formed. This is the new bond formation. New bond. New localized bond formation. Where the probability of finding an electron is maximum. Here the electron is there, for example, here only. So where the probability of finding an electron means sharing of electrons. Where the probability of finding an electron is maximum. If there is no electron, there is no overlapping. So where there is a probability, mean where the electrons. That is what by Hitler and London. Okay? This is about the covalent bond. So in this what we have to say, if the greater the overlap is there, what happened? Small the overlap and greater the overlap. If the greater the overlap, more will be the attraction between the 2 atoms to spin of electrons. For example, in this is the atom. Okay, in this one electron is there, up spin. This is the probability of finding an electron is the maximum here, and this is also here. Here, this one. The probability of finding an electron. Here, this is the maximum electron. Mean the probability is there, mean here the electrons are there. So these attraction of electrons. Greater the overlap, more will be the attraction between the spins of electrons. Okay, this is about the basic science. And some overlaps. I will tell you the discussion. Some overlaps. What are the overlaps? Overlaps. The formation of covalent bond, what is that? Involves the overlapping of off-filled atomic orbitals. The covalent bonds can be classified into two different categories. What is that? Two different categories. Upon the type of overlapping, you know that sigma covalent bond and pi covalent bond. Sigma covalent bonding and pi covalent bond. Sigma covalent and pi covalent bond. Sigma covalent bond and pi covalent bond. So what is meant by sigma covalent bond? So this type of covalent bond is found by the axial overlapping of off-filled atomic orbitals. What is that? This type of covalent bond is formed by the axial overlapping. Axial overlapping. For example, I will draw it here that this is the nucleus center. So this is the axial overlap. Axial overlap. S orbital, S orbital, SS overlap. If S orbital, P orbital, this is the SP overlap. So all these are what? In axial overlap. This is the formation is the sigma bond. Here the sigma bond. Sigma bond formation takes place. What is that? This sigma bond mean this type of covalent bond is formed by the axial overlapping. Axial overlapping of filled atomic orbitals. The atomic orbitals overlap along in the internuclear axis. Along the internuclear axis and involves end to end or head-on overlap. End to end or head-on overlap. The electron cloud formed as a result of axial overlap is a cylindrical. What is the symmetrical? What is the symmetry of this one? Cylindrical base there. Cylindrical. About an internuclear axis. The electron constituting a sigma bond are called sigma electrons. What is that? The electrons. Here the electrons are there. What are the electrons? The electron consisting sigma bond are called sigma electrons. There can be three types of axial overlap. Already I told you. SS overlap, SP overlap and PP overlap. So PP overlap means what is this one? This is the PP overlap. SS overlap, SP overlap and PP overlap. Okay? And next we will see that pi bond. This type of covalent bond is formed by the lateral or sidewise overlap. Lateral, not like axial, so sidewise overlap of the atomic orbitals. The atomic orbitals to each other, the atomic orbitals overlap takes place in such a way, the orbitals overlap takes place in such a way that their axes are parallel to each other. What is that? The parallel to each other, but perpendicular to the internuclear axis. Perpendicular to internal. The pi bond consists of two charges clouds above and below plane of the atomic involves in the bond formation. The electrons involved in it is a bond formation. I will draw it. So what is the above and same? But S orbital is not possible. Only P orbitals we can draw like this. This is the what? Lateral. So plus. This is the P orbital, and to form the here the overlap between the two orbitals. So the above and below. This is overlap. This one. sidewise overlap. What is that? This type of covalent bond is formed by the lateral side or sidewise overlap of the atomic orbitals. The orbitals overlap takes place in such a way that their axes are parallel to each other. Okay, the pi bond consists of two charges, one above and below the pi bond. So examples we can say nitrogen, oxygen. For example, in the nitrogen, like this. So this is the nitrogen. So this is one is the axial and one sidewise overlap. This is the sidewise overlap. So nitrogen is the triple bond. So two pi bonds, one sigma bond. And oxygen also, oxygen is the double bond. So one sigma bond, one pi bond. So pi bond, and sigma bond, like this. So we have discussed the many things today. Okay, sigma bonds. So once again, in the introduction, what we have discussed? Atom, molecule, Pauli's exclusion principle, orbital, principal quantum number, azimuthal quantum number, and overlapping, SS overlapping, PP overlapping, and SP overlapping, and bond formation. What type of bonds are present? Sigma bond, pi bond. Sigma bond is the internal axis, and pi bond is a sidewise overlap. So all these things we have discussed today. Okay, thank you very much. Bye.